students. Today our topic refraction of light. First of all, what is the light? Light is a form of energy when incident on any object and that it will be reflected from the object and reach to our retina give the sensation of vision is called as a light. Means the reflected energy from the objects reach to our retina and give the sensation of vision is called as a light. Light have a different properties. Light propagates in rectilinear motion. Light obeys reflection, refraction, interference, diffraction, polarization, double refraction, like that. And also it obeys the different properties depending upon their particle nature. Raman effect, Zeeman effect, Stark effect, Compton effect, photoelectric effect, and so on. But in our level, we want to discuss about the reflection, refraction, interference, like these concepts. But today, our concept is refraction. Okay, here already you know in your lower class what is the reflection of light. So what is the reflection of light means in the if light is propagating and it will be incident on any plane surface or any surface, the light will be rebounds into the same medium. That phenomena is called as a reflection of light. So already in your lower section, reflection due to plane surfaces, reflection due to curved surfaces are over. Here our topic is refraction of light. What is the refraction of light? When light is propagating from one medium to another medium, it means air to water. Medium means matter, substance here. Air is the one medium, glass is the one medium, water is the one medium, diamond is the one medium. In this manner, light is propagating from one medium to another medium. At the separation of the two mediums, at the interface of the two mediums, the velocity of light changes. The velocity of light changes and it the direction of the light also changes, except light is incident normal. Light incident normally. Means, I will explain clearly. Suppose if you take the one vessel. In this vessel, we fill with a water. Now, if you take the one stick, the straight stick, actually it is like this. So one of the stick we are taking, one of the straight stick we are taking. This straight stick we are arranging in the water. Like this. Actually we are like this. When you observe the stick which is inside the water, outside, you observe, you feel that it appears like that. At the separation of medium, it appears that it bends slightly. Okay, it means here it is appearing like this. Means when the light propagating from one medium to another medium, one medium to another medium, at the separation of the two mediums, here this is for example air, this is water. At the separation of the two mediums, the velocity of light changes. At the same time, it bends, light bends. Except light is incident normally. Means light is incident normally on the interface surface from one medium to another medium. Velocity changes, but there is no bending. Means let us, this is the one of the glass slab. If the light is incident, this is the normal line. For example, this is the normal line. Okay. If the light is incident like this, at the separation of two mediums, what happen? It will be bends. Means velocity changes and bends. For example, here velocity v1, here what is the velocity v2. At the same way, if the light is incident, for example, normally like this. So normally incident means the incident angle is equal to 0, refracted angle also 0. In these cases, the velocity changes, but there is no deviation. This is I'm going to explain. Okay, so this is the one of the explanation. It means once again, when light is propagating from one medium to another medium, the velocity of light changes. At the same time, the light ray bends at the separation of the two mediums, except when the light is incident normally on the interface of the two mediums. This refraction concept we observe in number of cases in our regular life. For example, the stick bends like this. At the same way, suppose if you take the one vessel, in this you take the water, and now if you take a small size of lemon, this lemon you are arranging in the water. As compared its size of the lemon, it appears big size due to refraction. At the same way, suppose if you take the one of the glass or mug, any one vessel you are taking, in this you pour the water up to certain level. At the bottom of this vessel, if you arrange the one coin, okay, if you arrange the one coin, then what happened? When you observe the coin which is at the bottom of the vessel in the water, it appears like that, slightly rise up. Means like this. It appears like that, slightly rise up. So why it appears like this means due to refraction. Due to refraction phenomena. So what is the mechanism is going on? If light bends, what happen? We are going to discuss. Okay? It's related. First of all, here we are using the words rarer medium and denser medium. Rarer medium and denser medium. What is the rarer medium? What is the denser medium? When, if you observe the two takes the two mediums, if you take the two mediums, for example, air, water, you are taking. When you observe these two mediums, which medium having more density, it is called as a denser medium. Which medium have the less density with respect to other is called as a rarer medium. Means with respect to water, air having less density, that's why it is considered as a rarer medium. As compared to the air, water having more density, that's why it is taken as a denser medium. Suppose if you take the water and glass combination, with respect to glass, water is acted as a rarer medium and glass is acted as a denser medium in this manner. Means actually with respect to air, water is the denser, but with respect to glass, water is the rarer. Similarly, if you take the glass and diamond, glass is acted as a rarer with respect to diamond and diamond is acted as a denser with respect to glass. Okay, clear? So here rarer and denser mediums were taken. If light propagating from rarer to denser, what happened? Or if light propagating denser to rarer, what happened? Here we are going to discuss. Suppose the light propagating from rarer medium to denser medium. Now, this is the rarer and it is denser. Let us, this is the normal. Now, this is rarer medium and this one is denser medium. Light propagating from rarer to denser, at the time the light ray bends towards the normal line. Light ray bends towards the normal line. Then the angle between the incident ray to normal line is taken as an angle of incident. The angle between refracted ray to normal line is taken as a angle of refraction. Suppose if there is no change in medium, the light will be propagate like this. In rectilinear motion, straight line it's travel. Due to the change in medium, it bends. So this angle is taken as a deviation angle. So delta is here deviation angle. In this case, rarer to denser medium light propagating, in this case, delta is equal to I minus R. Because here I is greater than R. Similarly, here, let us, this is the denser medium and this one is rarer medium. Normal to the surface. When light propagating from denser medium to rarer medium, the light ray here bends away from the normal line. Away from the normal line. In this case, the angle of incident I, angle of refraction is R. If there is no change in medium, the direction of propagation of light is like this, then this is acted as a deviation angle in this case. Here R is greater than I, it means the deviation angle delta can be written as R minus I. In the first case, the velocity of light in the medium we are taking as V1. In the second medium, means in denser medium, what is the velocity of light? V2. This is the one. So in the as compared to this is another case. In this another case, what happened? Here velocity we are taking the V1 and V2. Means in both cases, what we are observing? One medium to another medium, light propagating, velocity changing, and the light ray bending towards normal line or away from the normal line, depending upon the rarer to denser or denser to rarer. Here I am going to explain why light bends. What is the main reason? What is the reason? What is the cause to bending the light from one medium to another medium? It's related. Generally, I am giving one example in our regular life. Suppose this is the one of the road. This is the one of the road. Here the road, this portion is smooth portion of the road. This is the rough portion of the road. Means up to this one it is a smooth road, here rough road. Let us, if any vehicle, just I am taking one of the car, it's coming cross like this. It's coming cross. Means it's moving from smooth road to rough road, making certain angle. At the time, this is the one wheel of the car. Parallelly, this is the another wheel of the or another tire of the car. When you observe this one, these both tires or wheels coming with same speed. But this one left tire as compare the right tire, what happened? Early reached to the rough surface. Automatically, due to the roughness, due to the frictional forces, its speed decreases. When its speed is decreases, what happened? Its speed decreases means its speed is same. Means as compare the left side tire, right side speed is more. That's why what happened? Here this is the one. It's slow, but it's moving fast. What happened? It bends like this or not? Same way. The vehicle will be bends towards the normal line. Okay? Same way. If same car moving from rough to smooth road, same, it's making certain angle, transferring from rough surface to, means moving from rough road to smooth road. This is the left tire and this is the right tire. Okay. As compared the left tire, right tire speed is low. Means here when it reaches that one, both are having equal speeds. But when it reaches the smooth, automatically friction forces are decreases. Then what happened? The speed of the left tire is increases than right tire. So here I am taking here. So this is the left tire and the right tire. As compared the right, its speed is more means automatically what happened? It bends like this. Bend like. So same way, light bends away from the normal line. Means smooth means rarer, rough means denser. Rarer to denser bends towards the normal line. Denser to rarer bends away from the normal line. This is not for your related exams related, it's not important, but to understand why the light bends at the separation of the two mediums, that's why I'm explaining this example. Okay. Here, so overall from this concept, what you observe, light traveling from rarer to denser bends towards the normal line. When light is propagating, denser to rarer bends away from the normal line. In the example, suppose a car traveling straightly. What happened? No bending, but velocity decreases. Sir, here it's coming at an angle, no? That's why bends. But if the car moving from smooth road to rough road or rough road to smooth road, whatever maybe, it's straightly means both sides are move from smooth to road at the same time of instant, then speed only changes, but there is no bending. Okay. Now here, one more explanation here. When light propagating from rarer to denser or denser to rarer, the ratio of velocity of light in the case of refraction is constant. Means the velocity of light in rarer medium, suppose V1, and the velocity of light in denser medium is V2. For example, if you take this one, rarer to denser, the ratio of velocity of light from one medium to another medium is a constant. This constant we are taking as a refractive index. Refractive index means V1 by V2 we can written as mu in the form of mu. It is a constant, it's taken as a mu. This mu is called as a refractive index. So here, what is the refractive index? The ratio of velocity of light in rarer medium to velocity of light in denser medium is gives the refractive index of that denser medium. Or when light is propagating from first medium to second medium, it is either rarer or denser, the ratio of velocity of light in first medium to second medium is gives the refractive index of the second medium with respect to first medium. Means this is the one of the glass slab. Now the light, this is the normal line, the light incident from vacuum to glass, this is the vacuum to glass. For example, the light ray, what happened? Rarer to denser bends like this. Then the refractive index of the glass we can be written as velocity of light in vacuum to velocity of light in glass. This is the refractive index of the glass with respect to vacuum. Similarly, let us, if you take the water, okay, water, normal line, the light ray incident from vacuum to water, what happened? Here also rarer to denser bends like this inside the water. Just this is the path of the ray. Okay. Now, what happened here? The refractive index of the water can be written as the ratio of velocity of light in vacuum to velocity of light in water. Okay. Velocity of light in vacuum to velocity of light in water. So, in this manner, we find the refractive index of the denser medium with respect to any rarer medium. For example, if the light is propagating from water to glass, then what you can write? Mu refractive index of the glass with respect to water can be written as, what is the rarer medium here? Water. Or what is the first medium here? Water. So, VW by VZ. So, here I am taking all our examples rarer to denser. So, that's why I am taking velocity of light in rarer to velocity of light in denser. A common definition for refractive index means the ratio of velocity of light in a first medium to velocity of light in a second medium is give the refractive index of the second medium with respect to first medium. Okay, here mu ZW is equal to VW by VZ. Means refractive index of the glass with respect to water is equal to mu W by VW by VZ. Here I am going to explain. VW by C into C by VZ. Okay? CC cancel, we are getting VW by VZ. At the same time, it can be written as C by VZ into 1 by C by VW. Okay? VW by C into C by VZ. C by VZ, as is I am writing here. This VW by C can be written as 1 by C by VW. No change. Now, from this, C by VZ means, what is the value? Mu Z. And C by VW means mu W. So, from this explanation, what you can write? The refractive index of the glass with respect to water is equal to refractive index of the glass by refractive index of water. That is equal to VW by VZ. But you know very well, speed or velocity V is equal to nu lambda, frequency into wavelength. From this concept, what you can write? Nu lambda W by nu lambda Z. Here nu is the frequency. Nu is the frequency. In the case of refraction, the frequency does not changes when propagating from one medium to another medium. Already we discussed. So, in the case of waves chapter, so frequency no change means constant. So, nu constant, what you can write? Lambda W by lambda G. Okay, the refractive index of the glass with respect to water, we can written as mu Z by mu W, that is equal to VW by VZ, that is equal to lambda W by lambda G. Okay, from this overall explanation, we can be written like as refractive index of glass with respect to water is equal to mu Z by mu W is equal to Vw by Vz, that is equal to lambda W by lambda Z. Okay? For your understanding, I am taking the water and glass. Generally, when the light is propagating from one medium to another medium, or first medium to second medium, either rarer to denser or denser to rarer, whatever may be, we can written as mu to 1. Refractive index of second medium with respect to first medium can be written as mu 2 by mu 1 is equal to v1 by v2, that is equal to lambda 1 by lambda 2. From this explanation, mu 2 by mu 1 is equal to v1 by v2, that is equal to lambda 1 by lambda 2, means the refractive index is inversely proportional to velocity of light in that medium. Refractive index of the any medium is inversely proportional to velocity of the light in that medium, and inversely proportional to wavelength of light in that medium. Okay, here one more formula is there for the refractive index of the any material, that is nothing but when light is incident from one medium to another medium, or first medium to second medium, angle of incident I, angle of refraction is R. The refractive index of the second medium with respect to first medium can be written as the ratio of sine value of angle of incidence to sine value of angle of refraction. So here the ratio of sine value of angle of incident to sine value of angle of refraction is a constant. That constant is called as a refractive index. This is called as a Snell's law. This is called as a Snell's law. So what is the Snell's law? Generally, in the case of refraction, the ratio of sine value of angle of incident to sine value of angle of refraction is a constant. That constant is called as a refractive index. It is called as a Snell's law. Means mu 2 1 can be written as mu 2 by mu 1 is equal to sine I by sine R. From this, mu 1 sine I is equal to mu 2 sine R. This is the mathematical expression for the Snell's law. Okay. So, in next class, we are going to discuss about the denser medium to rarer medium refraction related critical angle and total internal reflection related concepts.